Hello everyone, my name is Tianren Wang. I'm a PhD candidate of the University of Queensland. Here is the work of our group, which is titled Faces a la carte, Text-to-Face Generation by Attribute Disentanglement. Referring to text-to-face tasks, there are several issues to be addressed. Firstly, natural language contains high-dimensional information, which is often less specific but also much more abstract than images. Second, the linkage between face images and their text descriptions are much looser than for popular text-to-image tasks, for example, bird and flower images. Lastly, emerging issues of data scarcity arising from the growing ethical concerns regarding informed consent for the use of faces scrapped from the Internet in modern biometrics research. Therefore, our work has the following contributions. We propose a novel TTF-HD framework comprising a multi-label text classifier, an image label encoder, and a feature disentangled image generator to generate high-quality faces with a wide range of variation. Second, we add a novel 40-label orthogonal coordinate system to get the trajectory of the input noise vectors. Lastly, we use state-of-the-art StyleGAN2 as the generator to map the manipulated noise vectors into the disentangled feature space to generate high-resolution images. Here is the diagram of our model, which includes a text classifier, a generator, and an image encoder, and a feature axis. We use 4 steps to manipulate the noise vectors to get the generated images. First, we use the differentiated outcome of diff to guide the noisy vectors to get the generated images. Second, we use nonlinear reweighting to give higher weights to the features to be generated. Third, then we normalize the vectors. Lastly, we lock the feature axis position where the vectors have been moved. And we conduct our experiment and we do a comparison between our work and a TANGAN in terms of inception score, cosine similarity, and LP-IPS. As you can see from the table, our work has a higher image quality and text-to-image consistency. And we also do another single sentence experiment. And as you can see from this image, in each line, the images are consistent with the features in the text description, but also have other diversity in terms of other irrelevant image features. We also conduct another ablation study in which we divide the experiment into 5 groups. As you can see from this table, the group A has a good inception score and text-to-image similarity, and the highest image diversity score. And also you can see from the figure at the right, the group A has the best image quality compared with other 4 groups. But also our work is not as good as it has some defects, which have to be addressed in the future research. Firstly, the text-to-feature accuracy in each image batch needs improvement. After our investigation, the image coder E is the bottleneck which needs to be improved in accuracy. Secondly, the features in the latent space are still not well disentangled. Inspired by GAN space, we plan to establish feature axes in intermediate space of SCAN2, which is also called W space, rather than the noise vector space extracted from the normal distribution. Then thank you. This is our presentation. Thank you for listening.